The self-similarity of fractals, as we saw with the Koch snowflake, can be generated by using recursive functions, which are functions that call themselves. The free CAD program OpenScad makes it really easy to play around with this idea. Something feels really strange and wrong about recursive functions. We're told never to use a word in its own definition, but that's what we're kind of doing here. So this is about the simplest example I could come up with that illustrates this idea. I created this module called corner cube, and you feed corner cube a point with coordinates x, y, and z, and a size, sz. So the first thing it does is it just draws a cube centered at x, y, and z with side length sz. Then, ignoring this if statement for a second, it calls corner cube, it calls itself 4 more times, and the coordinates it's being fed are the coordinates of the top 4 corners of the cube it just drew. Also, the size is cut in half. So what does it do? It draws a cube. It goes to the top 4 corners of that cube and says, draw a cube there, half the size. And then go to the top 4 corners of that cube and draw a cube, half the size on each of those corners. And then do the same thing. Go to the top corners of those cubes and draw a smaller cube on each of those corners, etc., etc. Now this would go on forever. Recursive functions have the same feeling of like when you hold a mirror up to a mirror. It goes on forever. But that's why we need this condition of size. You know, if size is greater than 4, then go ahead, call corner cube. But if it's less than 4, then stop. And you can see now when I call this function, I'm giving it the first point is just 0. So the first cube is going to be centered at 0. And the size is 100. And every time it calls corner cube, the size gets cut in half. So it's going to draw a cube of side length 100, then side lengths 50, 25, 12.5, etc., etc., until it gets below 4. So let's see what happens. So there we have it. This is a very cool looking thing. You know, it's just a very cool self-similar. You can see the self-similarity, you know, so this cube has 4 cubes on its top 4 corners. And this cube has 4 cubes on its top 4 corners. And then that cube has 4 cubes on its top 4 corners. You know, it's very self-similar and very fractal-like. And it was generated just using this very simple function. So you can generate all kinds of weird objects by using this strategy. And many famous fractals are created this way. Like you can look up the Menger sponge on Wikipedia and try and figure out how to draw that in OpenScad. It's relatively simple. An STL file is a list of triangles that define your object. I'll go into depth on this in the next video. I just want to sketch roughly the recursion I used to generate the Koch snowflake cup from the last video. So you feed the function a line segment, like this black line segment on the bottom, and it generates these 4 new black line segments, say 10 units higher on the z-axis. There are 6 triangles joining the old and the new segments here. 1, 2, 3, 4, 5, 6. So it sends these 6 triangles to the STL file and does that same thing for each of those 4 new segments. That's the recursion. So for this segment here, it makes 4 new segments, and that generates 6 new triangles, which it sends to the STL file. It does the same thing here. So with this segment, it generates these 4 segments, generates 6 triangles between them, sends it to the STL file, etc. It might be easier to see what I'm talking about looking at this rendering of the actual STL file that I generated. So, looking at this bottom part, that's actually 2 triangles. They're coplanar, so it just looks like a trapezoid. But 1, 2, 3, 4, 5, 6, and then you see that pattern repeats here, 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 and here, and then it repeats again up here. Again, I'll go into more details on what an STL file is in the next video. In the meantime, though, play around with recursive functions in OpenScad. I'll include this little sketch in the comments. See what happens when you change it. See what happens when you change some of the parameters, and try and come up with your own.